Okay, so my students, this week we're going to be learning a lot about fossils. And so we know that fossils are ways that, like James Hutton said, where we can analyze things in the present to find out about the past. And so I want to share with you a little story from my sophomore year of high school, my 10th grade year, and I am not making this up. So we had to do a major project in the first grading period that was an insect collection. And what I did was I let insects come into my screened-in porch, and I would capture them in a jar and freeze them to death. Then I had to make this display box. I have this red velvet fabric, and I had to pin them down, and we did not have computers like in every home back then. So we did have a typewriter. I had to type out a label with the scientific name and put it on there. And I remember very clearly some students waited till the last minute and their bugs didn't totally freeze to death and they were still flapping their wings like on the display boxes. So my question to you is, when I was freezing these fossil, or excuse me, I misspoke. When I was freezing these insects, did I actually create a fossil? And the answer to that is actually no. And here's why. So this is the first thing you'll put in your notes. Fossils are naturally preserved evidence of life. So when you think about it, I did do the second part of the definition for a fossil. I did have evidence of life. I certainly did not have naturally preserved, right? Humans can't preserve it. It has to be nature. So most of this is going to, this lesson is going to be, how does nature actually preserve fossils? And in some ways, it's very similar to how we keep food from spoiling. So we'll make those connections. Now, you'll notice your list goes from 1 to 6. The first one on here is the most common way by far that fossils form, and the last one on the list is much more rare, and we'll talk about why as we go. So this is the number one way fossils form, in sedimentary rock. And think about this with me. Bones and teeth and shells, they're really just little chunks, right? They're really just little chunks of sediment when you think about it. So they can get buried and cemented right in that sedimentary rock. And actually, ocean creatures are in the right place to have the shell sink down and be buried. But what you see here is not an ocean creature. This is actually a mammoth skull. And back a long time ago now, in 2007, my dad and I went out to South Dakota. We drove that one. We went to see Mount Rushmore and the presidents carved in the stone in the Badlands National Park. And we came back through as we were leaving the park, and I just read that there was this fossil site called Mammoth Hot Springs. And what was very interesting here, you can see this is a mammoth skull. There were 55 almost completely intact mammoth skeletons in this one spot. And when I say this one spot, the dig site was probably about the size of our school, but that would be super close together to have 55 almost completely intact skeletons. And so what they think is that it was a dried up lake. And as climate started to change in this middle part of our country, food became more scarce, watering holes became more scarce, and they think these creatures starved to death at their watering hole. But you can tell that the bones here are being excavated out of sedimentary rock. Okay, now the second way that fossils form is the second most common. Remember, like this goes common to rare ways. And this is called mineral replacement. Now, sometimes when students look at this picture, they're like, oh, I see rock layers, superposition, younger on top, older on bottom. That's all good, but that's not the fossil in this picture. The fossils in this picture are here, and that is actually petrified wood. So petrified wood is not wood, it's a stone. But here's what's happened. It's called mineral replacement. You remember from 7th grade how plant cells have a cell wall around them, and under a microscope, it looks like a rectangle. So as once trees die, sometimes they get buried in the right conditions that minerals dissolved in the groundwater can go in and fill up those cell walls. And what you end up getting is a stone that's an exact replica of the tree. So that's the story there. It's called mineral replacement. Okay, now here's the third way fossils form. Some of you have heard of this before if you've watched the Jurassic Park movies. So the third way is that fossils can form in tree sap, which is called amber. And it's not like saber-toothed tigers. Excuse me. Thank you. It's not like saber-toothed tigers have been trapped in some amber. It's mostly what we know about insects. So here's our list so far. In sedimentary rocks, petrified wood, where minerals go in and replace the living cells. And then we have tree sap here, amber. Now, here's the fourth way. And this way, I feel kind of sad for the creatures. So if you look closely, you can see in this tar pit some bones. And so what happens with a tar pit is that this thick fossil fuel naturally raises to the surface in some places, and creatures get stuck there. So there's a place in California, actually in Los Angeles, called the La Brea tar pits, and they found saber-toothed tigers there. And there's evidence they are trying to chew their own legs off to get out. It's bad news, but here's the story with it. Down in there, you have a lower oxygen environment and it can trap and then preserve. So that's preserve meaning not allow it to rot. So that's why. Okay, this one's a little gross too. So if you've ever had beef jerky or deer jerky or turkey jerky, that's basically like mummification. So this creature, he's obviously in a museum, but this is half of a prehistoric horse. And notice you can still see more than bones. You can see some muscle there. So this is mummification. And you might be like, well, why is this fifth? Like, the science behind it is that drying out takes water away, and the bacteria and fungus that would go in there and actually decompose the tissues can't operate. The reason that this is so rare is you need an extremely dry climate, like desert-like, and also hot helps. And so that would be the reason. Now, this last one, this mammoth baby looks like it's just sleeping. Nope, frozen to death. And so the story is that just like you could put food in a freezer and it would look, the same, this is what has happened to this creature. So the story goes this baby fell into a deep crevice and between the ice and froze. And they found frozen fossils that they can actually dissect their stomach and still see their last meal. That's how well preserved. So you might be like, well, Mrs. Fickus, why is this last on our list? Why is this so rare? It has to be a place in our planet that never gets above freezing, and those are not common to find. Okay, so those are the 6 ways fossils form. Now, I do want to share with you a little bit more about different types of fossils. So it's obvious when you find a bone, a shell, or a tooth, like you've got the real part of a creature. But if you go back up here with me, it doesn't say the definition has anything to do with it being the actual real part. So there are some fossils that are called trace fossils. And instead of being the real part, they're evidence of activity, but they're still trace fossils. And we have a few types to study. Okay, so sometimes I trick my students. I say, put your hand up if you see the shell, and all their hands go up. The truth is, you do not see an actual shell, right? So the mold, any mold fossil is a print. So this isn't always the print of a shell. It could be, for example, a footprint. That's common. Now, this cast over here is the filled in mold. So think of it like this. The mold's kind of like the cake pan, and the cast would be kind of like the cake batter, right? You can't have the cast if you didn't have a mold in the first place. And so there had to have been a shell right here to make the mold once upon a time. So molds and casts are trace fossils. Now here's another kind of trace fossil that you know about. Demonelix, right? This is a burrow. And remember, they thought they were plant roots until they found paleocastor inside. So what you should be writing there, though, is just burrow, that burrows are a common trace fossil, evidence of the activity of the creature. And then, you've already seen these guys. Here's the one that you might find to be your favorite trace fossil. This is called a coprolite, and it truly is fossilized dung. And so you're like, well, Mrs. Fickus, how the heck? Okay, so when you go to the bathroom, number 2, what you poop out is water, bacteria that help you digest, and also undigested plant material with cell walls. So trace fossils, the trace fossil coprolite, fossilized dung, is actually a case of mineral replacement. So if your poo gets buried deep enough and the conditions are dry enough, this can happen. Now, this is kind of crazy. I Googled the biggest coprolite ever, a 50-pound coprolite that was 50 centimeter long, and about 20 pounds. 20 pounds would be like 4 bags of sugar. And I know that it came from a dinosaur. And then finally, the last type of fossil is an index fossil. Now, notice the key word there is short. That's what you should be writing in. Index fossils are unearthed for a short time, and they're helpful for finding the age of rock layers. Let me explain. So when you look at this chart, You notice it's divided into the Paleozoic, Mesozoic, Cenozoic era. It shows these different index fossils. Now, here's the deal. These fossils only lived during this period of history. So if you find a rock with these fossils in it, you can point to the period right away without radiometric dating to know its age. So our next step in this unit is going to be doing a lot of fossil exploration.